4. Okay, we're going to look at the derivative function, f prime of x. This little mark, we just call it prime. The derivative function, f prime of x, represents an instantaneous rate of change that is the slope of a tangent line of a specific point. I'll read that again. The derivative function, f prime x, represents an instantaneous rate of change that is the slope of a tangent line of a specific point. Okay, now draw this graph right here and make a curvy line, because we've been dealing with curves lately. Okay, if we take 2 points that are kind of far away and connect them, okay, this kind of a line is called a secant line. Secant. That's a secant line. Okay? Now, if we want to know the instantaneous rate of change, like say at this point right here, we can figure that out using derivatives. Right now we found the slope of a line between 2 points, which is the average rate of change. And if we wanted to get to take, say, these 2 points, we still have another secant line. What if we can actually go to the point, the line that just hits that graph at that point is called a tangent line. This is a tangent line, and at this point right here is f prime of x, the slope of that tangent line. That's what this f prime of x is, the slope of the tangent line. Tangent line, again, it just touched the graph at 1 point. So let's read the definition again. The derivative function f prime of x represents an instantaneous rate of change. That is the slope of a tangent line of a specific point. So now we can know instantly what the rate is at that point, where before with the secant line we only had the average rate of change. Okay, so how do we find this? We had talked about limits, so let's do another one, another curvy line. All right, and we had mentioned if this is x, then this would be f of x. Okay, and then if we went some distance out, I'm going to call that h. This would be called x plus h. And this point here would be called f of x plus h. Okay? So now what we want to do, notice these 2 points are far away. Okay? And is this picture, as we get closer and closer and closer, what's happening as we get closer is h is shrinking. If we go from here to here, h has become smaller. This becomes our new point, and it's become smaller. And then here to here, it's become smaller. So we're looking as h approaches 0 is how we find exactly where that point is. So we're looking for the limit towards that point. Okay, so now I'm going to make another graph. We're going to make a couple in this lesson. Okay, if f prime of x exists, we say f is differentiable at x. If f prime of x exists, we say f is differentiable at x. Now here, let's just make a little graph. 1, 2, 3, 4. Make a curve out here. Okay. Now if this is at 2 right here, f prime of 2 is right here. It's this tangent line. It's the slope of the tangent line that hits that point. That's what f prime of 2 represents. So let's do another one. This is f prime of 4. And that would be the slope of this tangent line that hits just that point. Okay? So we say for this one, f is differentiable at x equal 2. That's how we would state that. Okay? We can also say f prime of 2 is the slope of the tangent line at f of 2. Or sometimes they just say at x, which means at 2. Okay? They'll say it different ways. So I'm going to erase this and say, this is another way of saying at x equal to 2.